Come here, Cooper. What's this? What's up there? Where are you going? You look through the window? So I feel like it's been a while. I think 9 days or something since I last upload, and whew, things have been rough. So let me just tell you why it's been so long. I uploaded that video about the vortex generators, and I went on a little bit of a trip for the 4th of July weekend. Came back and I was like, all right, it's time to get going with some projects. The first thing I thought of was, let's try to make a radiator from 3D printed material. I knew we were gonna have some issues because 3D printed stuff is not known for being watertight, but I had this plan on how I was gonna seal it and make everything work. And well, I got it to seal, but under pressure, I just couldn't get it to work. So I had to trash that one until I got until I upgraded my printer and able to print like some better material. I'm thinking ABS with some smoothing. I might be able to seal everything up, but I don't have nominal hot in it. So that led into like, why don't we just update the printer and get you guys a little update video on where the TiVo is, what I've done to it since, and putting on the new E6 or the E3DV6 hot end, which involved, you know, designing and printing and doing a bunch of stuff to get it mounted. I was gonna do it, I got started on it, started designing, and I was like, wait a minute, the Prussia's not here, and if I mess this up, then I'm kind of screwed on other projects until it shows up, and who knows when it's gonna show up. I mean, I ordered it on 6/10. They're looking like 7 weeks delivery time maybe. It hasn't even started getting built yet, so who knows when that's gonna be here. So I trashed that thinking, you know, we better not break something that at least is working until we got a new one. So then I was like, oh man, I got nothing. I got fans. As you guys see here, I've been testing different fan designs, trying to get something cool, but nothing's really came out. I mean, this one's pretty close. I have another variation of that I'm gonna try, but nothing that's worth like bringing you guys another fan video if we don't have any good groundwork. So then I was like, oh, and then somebody had an idea of getting a Peltier, whatever, one of those electric coolers, you know, hot on one side, cold on the other side. Wanted me to do something where I try to remove a radiator from a system and just use that. And I was like, that sounds cool, I'll do that. Ordered one, it was supposed to be here today, and it is still not here. So we're kind of stuck in a holding pattern. I also have an update video coming for this PC where I'm going to do some hardline water tubing, but I had to order some stuff for that, and that is supposed to be here tomorrow, but now it doesn't look like it'll be here till Tuesday, so we are up shit creek here with no paddle. So if any of those videos sound interesting to you, make sure you get subscribed, because eventually they'll be here. But today we're going to do something instead a little different. So with one of these guys. So this is the fan I literally use all the time to benchmark. I've taken them apart to use as test benches, and the one that I'm trying to beat in cooling performance. Now, if you're not familiar with this fan, it's brown. There's supposed to be a black version coming sometime this century. We haven't seen it yet, but it's a good, you know, it's a good radiator cooling fan. It spins at a maximum of 2,000 RPMs, and I've always wondered, what if you could get it to go faster? And you know, I made a video once where we made that 31 or 30 blade fan, and we put like a race quad motor on it and just spun her all the way up and yeeted across my room. That's what I wanted to try. So I was like, how can we make this fan spin that fast? And I was like, well, one, the motor's obviously not going to do it, but I have plenty of release. I have plenty of these Emax red bottoms, race quad engines. They're cheap. They do a good job. I mean, we've used them before, and I was like, you know what? Let's make this thing spin that thing, and see if one, the fan survives, because I'm pretty sure Noctua never had in their plans for this fan to spin any faster than 2,000 RPMs. So one, let's see if the fan holds together. If it does hold together, then we'll see if it gets any improved cooling performance, because there probably is going to be a point in the RPM range where we can no longer generate better airflow, because essentially we are just stalling out the whole disc because we're spinning so fast. So I want to see, can we get there? So can we survive? Can we get there? And then also, after it's all said and done, does this motor still work? Because, you know, electric motor, when you spin it, kind of works the opposite way and becomes a generator. So we're going to see if we're putting out any power. And after we're said and done, if we spin this thing real fast, does it still work when it's all said and done? So I think that'll be fun. We had a lot of fails this week, and why not just fail a perfectly good fan for science? So this is what I got. A lot of you, if you are a subscriber, you've seen my community tab where I posted a picture of this thing, And a lot of you are like, oof, your print quality is rough. And the reason for that is I printed this, well, I already broke it, one, but I printed this as quickly as I could at the highest, resolution. So like 3.32, which is pretty high for a 0.4 millimeter nozzle. And I printed it really fast, faster than the T-Bow was really comfortable with, which is why the quality is so horrible. And the idea was, let me just print it out, test it, and see if it works. And if it does, we'll make a video about it. But then I thought, what is the point of that? We tested here together, so we can fail together and see misery in action. So I printed out another one. This one's at 0.2 millimeter layer height. It's a lot better quality, and it should be a better version of this one. I think we'll still try this one, even though it has a blown out leg. I'll glue that back on there just to see if it's gonna withstand the torque generated by this Emax red bottom. And if it does, we'll try this guy. If it just blows the doors off it, we're gonna have to reinforce it. So let's get started, see where this ends up. Okay, first order of business is fixing this leg that's already broke off, which doesn't bode well for our design. But I like to use Weld-On 4 to glue PLA because it kind of, you get kind of the same effect you'd get with acetone and ABS, because it does start to dissolve PLA a little bit. So it should weld it just as tight as it was before. But I'm a bit concerned that we're going to be able to even hold the torque put out by this motor, given the feet are just falling off. It also doesn't take long to set. So if you've ever used this on acrylic, which is normally, you see it used for like making fish tanks and stuff, it literally dries in seconds. But as we wait for that to dry, I guess we can talk about the design. We'll set that to the side here. Here's the other one. So essentially we have a drive. So this right here is going to be what we're calling, so this is what we call the drive. So essentially the motor shaft goes through this hole in the center. These notches line up with the fan blade of the Noctua, and we essentially are just going to push the fan round and round. And the shape is just to try to give us some sort of smooth airflow over the surface. But there's really not much to it. And essentially this is just a frame that it sits in. So it sits obviously here. These are the same hole pattern as a fan hole pattern, 105 for a 120 millimeter fan. This is the mounting pattern for the Emax, the RS2205. Mounts in there. We're gonna have to solder it up to our ESC, and we're just gonna let it rip. So another thing I thought about doing was getting an Arduino out to control the fan RPMs with a potentiometer. But then I got to thinking about the last time we did this, and actually here's one of the fans from it. So if you didn't see the video, there was one of these guys that was made up of 30 something odd blades, and another one that was made out of 3, and we spun her all the way till the failing point, and it grenaded, obviously. And I didn't tell you guys this because I didn't know it at the time, but a few weeks later I was cleaning up stuff in this little room here, and I noticed a mark in one of my walls, and I went and looked at it, and there was a piece of this PLA stuck into the wall. So keep in mind, this is probably around the area we were in when we did that test, and that wall is a good 8 foot away, and a piece of the blade flew into it. So instead, in light of that, I was like, you know what, let's stay safe here. We're going back to the hobby transmitter. So this is my DX6, and essentially we're going to do the same thing. We're going to hook it up with the controller, and that way I can hook it up to the radiator, point it in a direction that if it does grenade, none of this important stuff gets broken, and we can be outside the room, far away from the action, and just let it go. Now normally you would use a LiPo battery to power this, 12 or 2S, 3S, something like that, 4S even. But I have a power supply, so that is what we're going to do. So I'm going to take this PCIe, so basically the connector you use for a graphics card, and we're going to find which one of them gives us 12 volts in ground, and we're going to use that to power this ESC. Right there. 12 volts. Got it. Now it should go without saying, you should never, ever modify a power supply, but that's why I'm doing it, so you don't have to. Also, anything you see me do, it's pretty much safe to say that you probably shouldn't do it yourself, so go ahead, just subscribe to me. I'll do all the goofy stuff. You guys stay safe. All right, so that goes in there, and we want this thing to spin. It's got arrows on it, but we essentially want it to go this way. So let's first make sure none of this touches each other, because one thing I do know is how to short stuff, so let's just make it, let's just be careful. Let's just make a temporary barrier, because if not, I'm sure I'll short it out. Heard a beep, so it didn't explode. Whoa, we got power. And we're spinning the right direction, which is lucky, because normally I got the wires wrong. But hey, let's put it back together. So good news and bad news. Good news, we're ready to go. Bad news, we're ready to go. So hey, safety first. I guess I was gonna just try to start it slowly, but the bad thing about these motors is they don't really like to slowly ramp up. So I'm gonna just kind of turn it on, head out there. We'll see if we can get it to spin, because we got some issues here. One being the fact that the TiVo struggles to print anything perfectly round, so we got a little wobble, so hopefully it doesn't break the legs. Secondly, the motor's facing the opposite way it normally would, so cooling might be an issue. I mean, there's a lot of things that could possibly be an issue, but we're just gonna turn it on, see how it works, and we'll go from there. So as you can see, I put a target on there, so if we can get it to spin up and stabilize, we can see exactly how many RPMs we are running. 2,000 plus is the goal. So turn this on and get out of the way. All right, retreated to a safe distance. See if we can get a little bit of spin on there. Oh. Well, that was a bit anticlimactic. So last time we used this setup, we had just a motor mounted behind a fan. There was really no drag on the system. It was able to spin freely, and therefore we were able to hook it to the power supply. No big deal. However, this time we have a bit more, and by a bit more I mean a lot more, resistance in this system, because the prints aren't the best. They're not straightest. They're not the straightest. So what we need is more power, because the power supply ain't gonna cut it. It's a good thing I still have my LiPo battery. So this is a 4S battery, so now we have 14.8 volts of power, and more power means more spin. So I really don't think there's any way that something in this setup or in this room is getting away from this without being broken. It's gonna be, the motor's gonna get smoked, the ESC is gonna get smoked, the blade's gonna get something's getting smoked, and we're gonna do it here. So the power supply, it's gone. So we need to take this, and we need to put this connector onto the ESC so we can plug into the battery and give it another shot. All right, safety glasses. Who's ready to see if this works now? All right, backing it up. Here we go. Oh, overloaded. Problems. So, a lot of you guys probably already seen this coming, but this motor is 2300 kV, and it just doesn't have the torque required to turn this motor, or yeah, basically this motor, this fan disc, and all that stuff. So we're in trouble. But I do have another motor. So this is a bigger motor. It was from a different quad I used to have. This is a 980 kV, so it should have a bit more torque. We're gonna lose some RPM, but we're gonna try it, because one way or another, we're gonna spin this fan really fast. So let's hook this up. The problem is it is quite a bit taller than the other one, so we need some spacers or something. We gotta figure something out to get this mounted up here, but we're gonna do it, and we're gonna try it, and we're gonna see what happens. Well, I got it to fit, so I made some spacers to give us the extra distance we need. The bummer is I don't have any screws long enough, so we had to get crafty and use some nuts. But we're on there, so now we'll see if a lower kV, higher torque motor can get us where we want to go. If not, we're gonna have to start thinking even farther out of the box. All right, let's see if we can do anything here. Oh yeah, she's got more torque. Okay, we'll let it just sit. See if we can get our tachometer to read. Hey, we're over the limit already. So right now we're just sitting right at where the fan would like to be. So let's keep going. Okay, I can hear vibrations, so let's see where we're at. 33,000. It's getting more vibrations. Let's see. We're losing a screw. You know what? Let me just back up. Let's blow her out. Okay. I feel like we're way higher than I thought we would be. Let's see what that is. $5,429. So the Noctua is doing work. It seems to smooth out. Here we go. I'm gonna back up even farther. Ooh, it's starting to hit the side of the fan duct. All right, let's see if we can break her. Ooh, yeah, I don't know. We're shaking free. What happened here? We lose a blade? We did, we lost a blade. Well, that was fun. Well, that's exactly what I was hoping it would be. So, success in that we made this strange device to rotate the blades faster than they would actually spin at any normal time. The lower kV motor with the higher torque was able to overcome the whole entire mechanism here. But you know, the funniest thing is the big thing about these fans is when they came out, the material they used was said to allow them to get the fan blades a lot closer to the shroud because they didn't want to flex as much when they're spinning. Yet, you know, we weren't that much faster. So the normal fan operates around 2,000 RPMs. We spun it to about 2,100. Things were looking pretty much normal. A little bit of, you know, vibration from my situation, not the Noctua fan. But then, I mean, up to like 5,000, 5,100-ish, it was still pretty normal sounding, but as soon as we went just a little higher, I don't know exactly what it was because we started vibrating so bad. I'm sure it was like 5,500, 6,000. We started to have contact issues with the shroud. As you can see from the inside here, there is just nothing. I mean, these blades have almost melted away. And then eventually that caused one of the blades to just straight up separate, and then it was all over from there. So we didn't really get to measure any cooling at a higher RPM. I mean, we could have measured at 2,100. We probably could have done 5,000, but given the fact that we started to get contact at a little over 5,000, we might have seen worse performance given that the blades were starting to flex more than they should have. But either way, it was fun. Actually, I'm curious now to see if we can take this off here. Does this fan still work? Or did we burn up the winding? So give me 1 second to remove this. We'll plug it in and see if it actually does work. This is just, this isn't a PWM one. This is a flex. So it's just a 3-pin fan. So you got power, ground, tack. But I wonder if it works still. So let me remove my Goof Troop mounting situation. I had no idea when I had no idea when I bought these motors for that quad. I don't know why I'm taking my time here. I don't know. When I bought these motors, I mean, years ago, I had no idea that eventually I was going to be doing something this goofy with them, but I'm sure glad I did because they've come in handy. I'm glad I had these lower KV ones because the The other ones just weren't going to cut it. Moment of truth. Does it still work? Look at that. It vibrates like, I don't know, I don't want anything to fly off there, but that is absolutely astonishing. I mean, you can see the damage done to this fan, to the blade tips. One of the blades is missing. The horrendous vibration that we must have caused. But in the end, it just goes to show you how well made these fans are and why I like to keep using them in all these goofy experiments. So, if you guys have any more ideas of things you want me to do, make sure to leave me a comment down below. It doesn't have to be making a fan. It can be breaking a fan. It can be anything you can think of. Just give me an idea and we'll run with it, because this is what it's all about, having fun, breaking stuff, and trying something else next time. So, see you later, guys.